Hello and welcome back to Dr. Logic Awkwardly Does Logic. Are you ready for some definitions? I'm going to start by turning the general kind of things that we were talking about in the previous video about the completeness of S5 into a precise statement so that we're all on the same page about what it is that we are going to prove. The theorem that we are working towards is this. So let C be the class of reflexive, transitive, and symmetric frames. Then, if we have some formula phi that is valid on the class of frames, then in system S5, we can give a proof of it. So it is a theorem of S5. That is the statement, the result that we are aiming for, that we are going to be proving. Now, as I said, the process via which we'll get there involves a lot of different steps, a lot of taking formulas, recasting them in equivalent versions, but with nice syntactic properties. So the first thing that we need to have an idea of is this concept of a modal normal form. Now, you might remember from way back, with propositional logic, we talked about CNF and DNF, conjunctive normal form and disjunctive normal form, where every propositional formula could be taken and converted into something that is either a conjunction of disjunctions of atoms or negated atoms, or a disjunction of conjunctions of atoms or negated atoms. And what we're going to do with the modal normal form that we're going to look at is sort of generalize this idea. So we're going to introduce a notion of modal conjunctive normal form. Now, you could also do disjunctive, but that isn't going to be, we're not going to use anything like that. So modal conjunctive normal form is the particular type of, it's a way of taking an arbitrary formula and converting it into something that is logically equivalent to it, but has a particular form. So a formula will be said to be in modal conjunctive normal form. So a well-formed formula phi is in modal CNF if it is a conjunction. Now, I'm going to add the caveat that it is possibly degenerate. I'll come back and explain what I mean by that. In which each conjunct has a particular form. It's either going to be, each conjunct is a disjunction, again with the caveat that it is possibly degenerate, and it is a disjunction of things that are either purely propositional formulas, so they include no modal operators, or are of the form box alpha, or of the form diamond alpha, where alpha is a formula that doesn't have any other modal operators. So where alpha is non-modal. So the disjuncts in these disjunctions are always going to have at most one modal operator. So this is another way to say this is that it will be purely propositional. So that is what it means. If a formula has this particular form, it is in modal conjunctive normal form. So what do we mean by saying that these conjunctions and disjunctions are possibly degenerate? What we mean is that you can have a conjunction that has only one conjunct. So for instance, P doesn't look like it's a conjunction. However, it is semantically equivalent to P and P. And so you can think of just P by itself as a conjunction with only one conjunct. Similarly, P by itself doesn't look like a disjunction, but it's equivalent to P or P. And so we can again think of P as a disjunction that just happens to only have one disjunct. So let's look at some examples of things that are modal conjunctive normal form and things that are not. So P is, because it's a conjunction, a degenerate one of a propositional formula. P and possibly Q is also in modal conjunctive normal form. P and possibly Q and necessarily P and Q is also in modal conjunctive normal form, because all of these are conjunctions of which each one of these is itself a degenerate disjunction. So let's look at something a bit more complex. Wow, I just erased through that definition. Hopefully you remember what I said and can figure it out if you don't. You can also, let's get something that actually involves non-degenerate disjunctions and conjunctions. So something like P or Q and necessarily P or possibly Q. This is something that is in modal conjunctive normal form because we have a conjunction of disjunctions of which each disjunct, this is purely propositional, this is of the form box alpha, where alpha has no other modal operator, and this is of the form diamond alpha, where alpha also has no other modal operator. So something that would not be in a modal conjunctive normal form would be something like P and, necessarily P and possibly Q, because here, this bit has a modal operator in it. We've failed to meet the requirement of B. Something else would be if you have P or Q and necessarily possibly P. Again, two modal operators. If you have something of the form, it's actually really hard to kind of come up with things that are obviously and informatively not modal conjunctive normal form. The most important part here is the fact that you can't have either two modal operators in a row or one that is kind of embedded within the scope of another. Hold on to that thought, because this is going to be one of the crucial things that we will have to deal with when we want to show, as we'll do in a later video, that every formula is equivalent to something in modal conjunctive normal form in S5. But for now, we'll just stick with that definition. So write down a bunch of formulas. See if you can identify. Are they in modal CNF? Are they not in modal CNF? Work through the different parts of the definition to understand when you've got something that meets it and when you've got something that doesn't. If you've got any questions, if you're uncertain whether you've identified something as being modal CNF or not correctly, stick it in the comments. I'll happily take a look. Until then, take care. See you later.